In this lecture, we're going to discuss the differences between physical and chemical changes. So, a physical change or a physical property is something that we observe that doesn't actually change the composition of the material. And so, if it is a collection of atoms in a pure substance, those atoms stay the same. If it's a collection of molecules that make up the substance, then those don't actually change the actual chemical identity of it. But it undergoes physical changes like boiling, melting, and these are both phase changes, so changing the physical state of matter from solid to liquid to gas. It may also be something like solubility. Does this substance combine with another to form a homogeneous mixture? The color of something. So water appears clear, gold has that yellow, shiny luster. That would be a physical property of gold. The odor that a substance has. Isopropyl alcohol, which is rubbing alcohol you might find in your home, has a very distinct odor. These are all examples of a physical property. And so changes that alter one of these physical properties, but not the actual composition of the atom or molecule. So it doesn't change how atoms are bonded together in a molecule, would be a physical change. So anytime that the identity of the substance actually changes, like how the atoms are bonded together and the order or the shape in that sense, then we would be talking about a chemical change. So chemical properties are properties that substances would display, and that demonstrates how their chemical composition changes. So this usually takes place over the course of a chemical reaction. So one example would be the flammability of gasoline. That's a chemical property, it's flammability, whether or not it'll ignite and start a fire in the presence of oxygen in a spark. Another chemical property might include corrosiveness. So when we talk about acids and bases, one of their chemical properties is corrosiveness, which means it will react with other substances and break them down in a corrosive manner. And so acidity then, or toxicity, how toxic something is to an organism. And all of these examples here require that substance undergoing a chemical transformation. And that's our main contrast to a physical property and to physical change. So then our chemical properties, when a chemical property for a substance or the composition of matter changes, we're looking at a chemical change rather than physical. The classic example that I always go to is the spontaneous reaction of an iron nail rusting. So iron atoms, when exposed to oxygen, will form iron oxide, which is rust. And it's changing the bonds from just here we have just iron atoms bonded to other iron atoms, to here we have iron atoms forming bonds to oxygen atoms. And that is a fundamental change in the chemical composition, the fact that we're binding oxygen and iron together rather than just iron and iron. And so that rusting of an iron nail is a chemical change, an example of it. Another example might be something like when you make toast. You have a soft piece of bread that becomes harder and the color changes, and we see that the smell changes, and it's undergone a Maillard reaction, making it infinitely tastier. But we sometimes notice these chemical changes by observing physical changes. So sometimes a physical like a physical property change can indicate that we've actually had a chemical composition change.